Hi, you guys. This is part 2 of Chapter 12, Evolutionary Thought. In this section, we talk about how this thought changed over time. So this is a timeline, and we go way back to Aristotle. And the question here, all the way through, is, do species change? Okay, or do they stay the same? So if we go back to Aristotle, who's thinking that individuals in a species are basically identical and species are unchanging. So that's where we start from. Then there's a break in my line here. We go to 1749, and Buffon here is thinking species change maybe when they spread, when they go from one location to another one. And this is that evolutionary thought. 1800s, Lamarck says, I think new species do emerge, and they actually come from existing species, and something to do with the environment is forcing this change. And he wasn't really wrong. He was wrong in parts of it. Lyell, all changes in nature are very gradual, and we move on to Darwin and Wallace, which were mid-1800s, and they really thought about this a lot. And they thought, change does happen. We have to say that change is happening. And maybe the world is older than we think. Okay? So that was the progression of thought that was going on. One really good way for us to study this is with the use of fossils. So they will provide evidence, as I'm telling you here, for slow change over time. So if you were to get a mountainside, let's say, this mountain here, and you have these new layers that are on the top, right? They're deposited more recently with new deposits on the top, and then the older, deeper rock, which is below. So you would expect then that this would have more recent fossils on the top, and the older rock would have much older fossils down below. And the reason we're so interested in fossils is because maybe there's animals that are extinct. We can't study them today, but we can look at the fossils, the leftovers of those animals, and see how they resemble those today. And maybe they were a common ancestor. So that term's going to come up a lot. Common ancestor, right? Because we're thinking of modern organisms that are derived from some older organism that was the ancestor to this modern species. So we have found millions of fossils, and clearly they're not the same age. And this has happened all over the world. And so what geologists have done is that they've built world maps saying, okay, maybe the age of this is such in such an area, and get an idea of, when you go digging in layers, of how old these layers are. They've also named these different periods, and I'll show you some maps of that. And these are just some fossils here of a very cool organism called a trilobite. And these, we used to go hunting for these when we were in grad school. Super fun. We lived by a place where they blasted out the mountainside and sold, rock and sand. And on the weekend, we'd sneak in and go and dig around the rock there that had been blasted. And we would find these trilobites. They are, ancestors to a modern arthropod, and they could be 400 million years old. I never found a whole one, but, pieces cut off of them. And it's just very fun to do that. So if organisms became more complex through time, then we think that the sea creatures, that were the first creatures, would be very deep, and mammals more superficial. And we know that there would be no human fossils in the time of dinosaurs, correct? Those don't overlap at all. And no dinosaur fossils in the time of these trilobites. So there's definitely a succession over time of these organisms. And we can study those layers as a succession over time. This is how you would look at that geological history. First, it's divided into eras. So very old, Paleozoic, middle old is Mesozoic, and then today more Cenozoic is the most modern. But between those, I mean, you have to cut these up also into periods because there's distinct times where things happened. So there's distinct times when you only see, leftovers of certain organisms, as in the Silurian, where you start seeing, fish. You come up into the Devonian, and there's plants now, which are terrestrial. This terrestrial and Silurian also. Terrestrial organisms, but no flowering plants, for example. And you go moving up into both complexity and differing species that are occurring over time. And this is what geologists do. And if you were to give it years, how long this lasted. This is, for example, 540 to 480 million years ago. And we would climb up here and how many years these different periods lasted. The Earth, we think, is about 5.2, 5.5 billion years old. And we believe life started at about 3.8 billion years ago. In this last era, the Cenozoic, there is a division here all the way from the Paleocene. We further divide into epochs. So you would have the Paleocene, the Eocene, the Oligocene, the Miocene, and these are all the different epochs, again, dividing it into smaller pieces that identify what happened during that time. We are right in the middle, or geologists are right in the middle of trying to decide what epoch we're in right now, because a lot is happening in this living world. And so this is a cartoon, and I'll just let you read it for a minute. So the thought is that maybe we have a new epoch going on right now, the Anthropocene. And anthro means human, related to humans, because we have had such influence on our Earth. And maybe that's the name of the next epoch. We want to always refer back to Darwin when we talk to evolution. We talk about evolution. He was the naturalist on the Beagle, the boat, the ship that was mapping all the coasts here of South America. And he traveled around the world on the boat because they figured it would be nice to have someone who was a biologist and was interested in natural history and could collect specimens and ship them back to London. And if they sent them back to London, then the biologists and botanists there could look at these specimens and learn a little bit without having to do the trip themselves. One very important study that he did was on the Galapagos Islands, which is an island off Ecuador here in South America. And he looked at birds because he was interested. He started to notice, actually, that these birds looked alike but differed a lot in their beaks. And that got him thinking that maybe they had a common ancestor that was on the mainland. And somehow one of those birds, when some amazing prevailing wind, had landed on the island. And then once they were there, they had diversified and become very many different species. That was his hypothesis. So he described 14 distinct types of finches. They were all different, and they had different beaks, and they behaved differently, and they ate different seeds. And he hypothesized that, as I said, they had a common ancestor that lived not on the island, and this has taken a long time to happen, a long time for these species to specialize on different kinds of seeds and become the birds that they are today. And that was scary to him. It was scary to him because he realized that the earth probably wasn't 6,000 years old as they thought it was, that perhaps it was millions or hundreds of millions. And that was very scary. He didn't dare say that to many people. He hid around in his house and wrote The Origin of Species and sort of stayed secluded in fear of the outcome of how this information was going to be received. So I'm going to stop there for another mini lecture.